we'll be talking about how populations grow. Let's talk about some concepts and vocabulary. Population density is the number of individuals per unit area. In general, there are three ways that individuals in a population inhabit a space. Random, when there is no pattern to where individuals can be found. Uniform, when individuals are evenly spaced apart. And clumped, when individuals form groups across the area. Age structure is an important aspect of a population too. Age structure is the number of males and females of a certain age in a population. It's important to notice that age isn't always measured in years. For flies or bacteria, you can measure age in days or weeks. When filling out your own age structure table, be sure to specify what organisms you are recording and to put a time unit on each age class. When immigration occurs, individuals move into an area already occupied by an existing population. Emigration is the opposite of immigration. It's when individuals move out of an existing population. Can a population grow without limits? The carrying capacity is the largest number of individuals a particular environment can support. Limiting factors help to determine the carrying capacity by decreasing population growth. Density-dependent limiting factors depend on population density. Think of this that as the population grows, a certain resource becomes scarcer, which limits population growth. Examples of this are food and shelter. Density-independent limiting factors do not depend on population density, so they affect a population regardless of the population size or density. Examples of this are oxygen supply in normal circumstances and temperature. Changes in population size can be mathematically defined by the equation on the right side of the slide. Notice that the triangle beside the P at the beginning of the equation represents a change in the population. The next term in the equation represents individuals entering the population by births, represented by B, and immigration, represented by I. When individuals enter the population, the size of the population increases. The last term of the equation represents individuals leaving the population by deaths, represented by D, and emigration, represented by E. When individuals leave the population, the size of the population decreases, hence the minus sign before the last term. All populations grow and shrink in this way. So here's an example with fish. Researchers have studied populations to come up with that equation we saw a few slides ago. But what methods do researchers use to study a population? A common method is to find an organism's geographic range, or the area the organism is found. Here we see the range for the orange-throat darter across several states. Researchers also observe how organisms are distributed across their range. Remember, the common distribution types are random, uniform, and clumped. Growth rate, or how fast or slow the population is growing, is also an important aspect of a population that researchers study. We'll talk more about this later. Age structure is also studied by researchers to see how individuals in a population age. This data can be shown in a table, as we've already seen, but it can also be displayed in a graph. Note here that the bars are percentages of a population, not the number of individuals per age group. Back to population growth. There are two types: exponential or unrestricted growth, and logistic or restricted growth. Notice that the pattern of growth, shown here by the blue line, is different in both types. In exponential growth, population growth continues at an increased rate as more time passes. In logistic growth, on the other hand, population growth slows down as time passes until the carrying capacity is reached. Determine the carrying capacity. We discussed before, these are limiting factors and they influence the carrying capacity. Competition, a density-dependent factor, occurs when there aren't enough resources, such as food and shelter, for all individuals. Individuals that successfully get a resource will survive and reproduce, while unsuccessful individuals won't reproduce and might not survive. Predation can also affect the carrying capacity. This factor is density dependent as well. Think about it. If the density of the prey item is high, then a greater amount of predation will happen. If the density of the prey item is low, then predators will have a harder time locating and killing prey items. Parasitism and disease keeps population growth in check too. If the population is dense, then the chance of individuals dying of disease and parasites increase. Because of this, it is a density-dependent factor. Unusual or extreme weather, such as a thunderstorm or just a drier summer than usual, can affect population size and growth. This problem can affect a population of any density, so it is a density-independent factor. Natural disasters, such as tsunamis, tornadoes, earthquakes, and volcanoes, not only kill many individuals in a population, but also greatly reduce resources such as food and shelter. Natural disasters can affect any population, so it is a density-independent factor.